Hi guys, so this is the GTX 570 and we've been waiting for some parts for this, and they arrived back end of last week, so I thought we'd have a look at see if we can complete the repair on this one. I will link the previous video, but to remind you, we had a low resistance of about 10 ohms on this power supply here, two-phase power supply, which is for the video RAM. We trace that, we know it's video RAM. It also powers part of the GPU. This is where the two inductor coils were, which I removed to prove where the short was. These are the high side and low side FETs, which also were removed. We turned out we had short circuit on the high side FETs, which is a bad thing because it means high voltage may have got into the memory. And it turned out the low resistance was actually this chip here, which is the controller chip, which has got a hole in it. Let's just zoom in and you can have a little bit of a closer look. Okay, so this is the controller chip, APW7088, and I ordered these. I ordered a little pack of them. I've got 5 of them here. We'll just check they are the correct part. This is actually those are some of the FETs. That's not the controller chip. Let me see if we can find the controller chips. They must be here, I'm guessing. Let's open the package. Let's have a look what we have here. They make this one difficult to get into. And normally these things come over when you don't want them to. Okay. Yeah, so these are the controller chips. Let's have a look, turn this over. Yeah, that's the one. So let's have a look to see what parts we have here and make sure we actually have the correct parts. The FETs were from here, high side and low side. I made a note of which ones are which, and this is where the two inductors are. Let's get under the microscope and have a look at the replacement parts and make sure we've got what we need. Okay, so here are our spare parts. We have the high side and low side FETs. The K0392 are the low side. I misidentified this on the previous video as being K0389, but the pinout didn't match, and somebody pointed out to me it's actually a K03B9 and the pinout does match, so that's the upper side. I ordered a pack of 5 of one and 10 of the other just because that's how we came in the best deal, really. I only need 2 of each, so it just gives me a few spare ones. And this is the controller chip, the APW7088. The FETs, I'm sure you would know. Let's just get another something to let's find some tweezers. Let's find the tweezers. Okay, so the FETs will have a large metal tab underneath them. Yeah, this is common for FETs. These are not too difficult to solder, to be quite honest, with hot air. The controller is a QFN, and these are a bit of a pain in the arse, to be quite honest, especially this one. It does have legs up the side of it. It's a 24 pin, so there's 6 pins either side, and I'm sure if I just get into the light you can see, I hope, the light there. Can you see them now? The legs come up the side, but whether there's any connection between the legs and the side and the pins underneath, I don't know. And that would make a difference to soldering. I'm going to try and solder this using a preheater and hot air. On the board, if we look at the board, move these out of the way one moment, we can see where the FETs came from quite clearly. I say these are not difficult to solder normally. I'll just put some leaded solder on here and try and solder them with hot air, and I might just come in with a bit of the soldering iron as well. I'll probably do these pins with the soldering iron if I can, and then use hot air to just tag these down. The only issue, if you like, I might see a bit with this is that the controller chip is directly underneath. Where is it? Oh, there it is. Yeah, I see it. There it is. The one with the hole in. Yeah. The controller chip is directly underneath the FETs. And if I try and fit the FETs first and then remove this, what will happen is a leaded solder might melt on the other side first. I don't want them falling off, basically. Lead free takes higher temperature. So I'm going to remove this first. I think I'll then replace this. This is the more difficult one. Put some Kapton tape over it. Hopefully keep it in place and then work on the other side. Because I'm using leaded solder, it will melt before any of these nearby components do, so at least I don't have a problem with those. Looking at this one, I have one resistor here which is close by. These are all effectively through holes. There's another resistor or something here close by. The rest are further away. I'll probably put a bit of Kapton tape up here just across that one, so not too close to the chip. I'll try to get some Kapton tape, and then I'll just try hot air on this, and hopefully it will unsolder. As you saw on the replacement one, there's a big pad on the back of this, right behind it, soldered to the board. So getting leaded solder around the edges probably isn't going to help a lot. I will anyway, and a bit of flux. Okay, so let's see what we can do to remove this. Get some flux on it. No, actually get some Kapton tape first. That's going to be the easiest, I think. Let's get some Kapton tape so it's not stuck into the flux afterwards. Let's try this. So I'm not worried about most of the components here. Only the ones that are very close. There's a resistor or capacitor here that I'd like to just try and keep down if I can. This is not so much about it, the unsoldering coming off. This is more to do with when I'm trying to remove the part with the tweezers. That often the pad underneath has like a surface tension, and sometimes they slide. They can be difficult, yeah, to pick up. It's more to do with that, really. Whether this will strictly help, I don't know. We can but try, as they say, yeah. We can but try. Another resistor or something just here. Let's keep that one held down. Yeah. And the rest I think are far enough away not to have to worry too much about it. Okay, that's that. Now let's get some flux on it. I think in fairness it's not worth trying to get leaded solder on these. There's nothing to really solder to. We can but try. Hope the microscope doesn't freeze. Actually, a loop down through the microscope helps me to do this. Nice big chunky tip to get some heat into it. Because most of the terminal is underneath the chip, unfortunately this doesn't help you as much as you might think. Okay, let's turn it around a bit. Some solder again, find the end of the solder. Okay. I've got the solder now, where's the end of the solder? There it is. Okay. On that, let's come down to the last side. Okay. Let's go back to the overhead camera. So I've got the hot air on 450 degrees centigrade, maximum airflow, and I'm first of all just going to go around this. I've got the graphics card balanced on. It's the lid off an old satellite receiver. This has like vents in it, yeah. I'll use this as much to protect the anti-static work mat as anything else, to be quite honest. Which also means I'm not heating up the entire bench, so I'm trying to heat up this, yeah. I'm going to come in left-handed as well. So turn this around. Yeah, I'm going to come in left-handed, so I've got the right hand free to pick up the chip. Being right-handed, it's better for me if I can do it this way. Still just warming the area up. Okay, now I'm going to get a bit more to the thing itself. Starting to heat, so I just want to lift this, clean off the board if I can. Here we go. This is proving quite difficult. It's off. Just take your time with that sort of thing, guys. Just take your time. When there's a lot of heavy ground plane and power planes, that's going to happen. That was even with the quick 861DW, which is quite a powerful hot air. Okay, let's wait while that just cools down. Okay, so that came off quite cleanly by the looks of it. All looking good. So let's just clean this up with some bit of ISO, and then I'll try and replace the old solder with leaded solder. So let's just give it a clean. See what we have in this area. Board's still a bit warm, it's not hot anymore. It's, you know, feels like about as warm as like a pasty or a pie. Warm as toast, but not hot. Okay, so that's nice and clean. It's come off nicely. There's a bit of a like a ridge of solder in here which I need to flatten. So let's get some leaded solder on, and then let's get some solder braid and clean this all up ready for replacement. Right. So some leaded solder. That centre pad, I can feel there's a lot of thermal mass in that. Yeah, I can feel you effectively at the end of the soldering iron kind of sticking to it because it's drawing a lot of heat, which is probably why there's so much time to actually desolder. Let's get some braid on that, a bit more flux. Or does it actually need any braid? I'm not sure. That might be flat. It might be flat enough. So have we go again. If I can't do it this time, I'll use a bit of braid. That was pretty flat, that. Let's have a look at yeah, there's a ridge there. Okay, let's just get a little bit of braid on this. I thought I might be able to do that quite cleanly without, but it's almost playing ball with me, but not quite, yeah. So bit of braid. Rather big bit of braid, bit too big, never mind. Bit of flux. Add a little bit of solder to the tip. And just a small amount. This has a very high thermal heat capacity, if you like. It's sticking. It's stuck to the board now. Bit more solder. Like with tweezers. Let's see if we can lift it off, otherwise I'll get a bit of hot air in as well. Yeah, so it's a very high thermal mass. Hot air. Soldering iron on boost. It's off. Okay guys, that's what happens when you use braid when you didn't really need to. One thing that has proven is that we're going to have to use a preheater on this from the other side to successfully solder the replacement. It's not just going to solder. Okay, let's clean that up and see what we've got now. Okay, it's clean. Okay. Right. That's looking good and clean. Can you see, guys, there's a little arrow here. Yeah, so that's pin 1 of the chip, and it counts anti-clockwise. And the chip's marked with a dot in the same corner, so that's how we know when we orient the chip in the right direction, yeah? Okay, that's looking good and clean. Let's get the chip prepared. Okay, so this is the chip itself. APW, you can see it at 7088. You can see the dot bottom left hand corner, yeah, by the tweezers. So that's pin 1. You hopefully see now that the pins do go around the side. Whether there's conduction that way, if you know what I mean, I don't exactly know. Whether, you know, if I put a meter probe on the side and one underneath, would I actually see a connection? That's interesting. If I do, that might make it a little bit easier to solder this. Let me just get the test meter and see if this is actually possible. No, I've not tried this before, so let's see. You can hear the bleeping, yeah? You don't need to see the meter, you can hear the bleeping. I'm interested to know whether, if I can connect to one of these pins on the chip, do I get a connection at the side, if you see what I mean? No, I don't think I do. I think I'm just sliding up. No, I think it's only on the edge. I don't think those that look like sort of little metal tabs on the side really are, or at least they're not. These things on the side look like they're not actually connected to that. I mean, they look physically like they are, but I don't think they are. Okay, let's not mess around with it anymore. Let's get the chip ready for soldering. So the way to do this is going to be just to try and get some a bit of solder on all the pins itself, yeah. I'll set some flux on the chip. Yeah. A little bit of solder on the iron. I'll hold the chip down and see if I can actually manage to tin this with some leaded solder, because that will make it much easier. When I say much easier, it'll make it easier. Nothing about QFNs is very easy in my opinion. Okay, there's a bit of solder. Let's try to hold it in place. See if we can get some onto it. Oh, that's nice. Turn around. Don't want to get too much on the middle pad. If you get too much on the middle pad, it kind of like raises the chip up, yeah? So it doesn't sit flat. Just get the crap off the end of the soldering iron. Let's see if I can actually. I'm just wiping the solder off the iron now and going back onto the centre pad and seeing whether I can actually reduce the amount of solder. Braid would probably take too much off, yeah? Let's go again. The idea of this is to try and get the centre pad and the pins with like an even amount of solder, so they both raised up evenly. That was pretty good. Okay, let's go with that and see if we can get this thing to solder. Okay, so we can see that this pad in particular, the middle, has a very high thermal mass, yeah? So we're going to have to use a preheater on this to warm from the other side, yeah? So warm this side of the board. I'll try and get up to about 180 degrees, almost. I'll even try and actually solder it as best I can from the other side, then bring in a bit of hot air for the last moments. What concerns me is this capacitor, which is very close, because obviously with the preheater under here, if I want to get this side to about 180, this side's going to be pretty hot, and A, it's not good for the capacitor, and B, it might just explode and make a right mess. So I think safety now, we'll remove this capacitor as well, yeah? And then we can soon put it back on afterwards, once we finish the rest of the soldering. So let's remove this capacitor as well. The blue is towards this edge, yeah? I have a shocking memory occasionally, so I'm just going to take a photograph. It's always good practice to do this. Okay. I have a photograph of that so we know which way around it goes. And now let's get this off. These are normally quite easy to desolder. I say normally, yeah. Try not to use hot air. I mean, you may have to warm the area, but again, you don't want to be blasting hot air directly on these capacitors. You don't want to explode them. I mean, 180 16 volts. I've probably got suitable replacements, but you know, let's try and make life easy for ourselves, yeah. Okay, so I'm going to come in with some leaded solder. Again, probably a little bit of flux as well, just to help it. And let's see if we can remove this. Again, the problem being the high thermal mass in this area, the board is not going to help us. So I just tilt it a little bit. Also, I don't want to be ripping the pads off, obviously. So I'm going to persuade it gently to come off the board if I can. Another one that doesn't want to give it up easily. I'll just warm it up somewhat. See if we can persuade it now to to come off, yeah. I use the thicker solder. If it's not going to come off, then we have to use the hot air. But I'd still rather take it off rather than have it sitting over the preheater for a long time, yeah? Okay. Let's get the lid off the satellite receiver. Let's just try and persuade it to come off quickly. Keeping my face well away from it, by the way. Try not to hit directly on top of the capacitor either, just trying to hit around the sides of it. Okay. It's off. Put that on one side. Now I'm happy now to put this on the preheater. You see what I was doing there? I was trying not to put the heat directly on the capacitor. I was trying to keep it around the edges of it, yeah? Just be a bit wary of them things, guys. I haven't exploded many, 2 or 3 in the past. Okay, so let's get the preheater and let's see if we can solder this chip. So just before soldering this, I've added a little bit more leaded solder to the pads, yeah, on the board. So what we're going to try and do here is basically place the chip in place on here with a very small amount of flux, yeah, and then get the preheater underneath the board to warm the entire board from underneath. That should then hopefully allow me to solder this. So this is the chip, yeah. And again, there's a little bit of solder on the pads. We want a very small amount of flux on the board, but a very small amount. Don't want it floating around, yeah. That's probably too much. I have a little paintbrush actually. I can just use a little paintbrush just to dab the flux around here, yeah. So a small amount of flux on. That's probably enough. I mean, there's a bit of flux under the chip anyway. We need to find out which is pin 1 on this chip, which is the one with the little dot. It's covered in so much flux I can't see the dot. So I'll have to just clean that off a little bit, and then we can see which way around the chip actually goes, yeah? So I've just cleaned the bit of flux off the top of it. You can now see the dot there, yeah? And that dot actually corresponds to the little arrow here, yeah? So that's the way around the chip actually goes. So now this is a matter, I think it's probably not enough flux now. Now I've cleaned the chip off, it's kind of like gone a bit dry underneath again, yeah? This is a matter of just trying to get the right sort of amount. So let's try that. Dots there. So now we try and put the chip in place. If it's close enough, it should do, because once the solder melts, the surface tension of the solder should pull this into place on its own. Yeah. So we just now just try and get as close as we can. That was pretty good. I'll try my trick now. This doesn't always work. The trick of actually trying to tack one pin down to hold it in place. Yeah, doesn't always work, to be quite honest. But we can give it a go with nothing to lose. As you can tell by now, I don't like QFNs very much. They're nasty things. Whoever came up with this stupid idea, yeah. I mean, well, so it's a little, bit of leg sticking out the side, so to speak. Left-handed's no good for me. Left-handed doesn't work very well for me. Let's try from the other side. One moment. Soldering iron in a knot. The lead to my soldering iron managed to get tangled up with the lead from the vacuum desoldering tool. Can we hold this thing in place? Nope, doesn't look like that's going to work. Okay, let's just try putting it into position and then using the preheater then. So there's the chip. Shame I couldn't do that, because it would have just kept it firmly in place. The reason being is probably because, like, the solder's kind of like raised up. I put little bumps on each of the pads, but I need some solders for the thing to melt. Yeah, if it was sitting flat, it'd stay in place while I did what I was trying to do. Okay, I think that looks to be very, very good. Let's prepare the preheater and see if we can solder this. Okay, so it's on the preheater. I can't quite get the chip centered over the heater because there's like the connectors on the GPU, the 12-volt connectors, are stopping me pushing it back far enough, but it's not a problem. So let's start to apply some heat. Ideally, I would like to solder this from the back side, from the rear of the board. Yeah. If I get it up to about 200 degrees, that will be enough. So I've got the thermocouple here close to the chip. Yeah. And we'll just start warming it. This will take some time due to the thermal mass, so I'll just pause the video and you can come back and join in when the fun starts. Okay, well, even with the preheater on the high setting, I'm still struggling to get anything like enough heat into this to solder it, so I'm going to have to use the hot air as well, which I'm now going to set to 450 and reduce the airflow down to about 20%. Yeah. So I don't want to blow this chip away. I'll probably have to use the magnifier a little bit as well, so I can see where I'm going with this. Well, let's try like this anyway. Try it without the magnifier. I'll just look directly on it. I need to get it to about 220, I guess, for the leaded solder to melt properly and hold it in place. So I'm actually about 120. If I just move the hot air away for a moment, you'll see where the real temperature is. I'm not totally convinced the thermocouple's reading correctly either. Okay. I'm thinking that might have it. It looks a little bit like the solder's melted. Just let me check the magnifier in on here. No, I'm not convinced that's even got it yet. Let's try increasing the airflow a little bit. At risk of blowing the chip off the board, but we need to solder it. Increase the airflow a little bit more. 45. Now I think I might have it. Get a bit more air now. I believe it's actually melted the solder. Up with the air again. I'm certainly glad I desoldered that capacitor. Okay. Let's see. Let's see how that goes. Switch it to cool and let it cool down. Okay guys, so set the microphone. So I've just give it a clean and let's get under the microscope. So that's the chip. We can clearly see it's on the right way round, which is a good start. Yeah, so the dot there is by the arrow on the board there, yeah. So it's the right way round. I'll just look down the microscope myself and let me just see if I can get this into good focus view while it's in good focus for me. Let me just adjust the focus on the camera itself. There. Easiest way to look at this is to use the torch. I find so we shine in, just tilt the board slightly so we can see, just look at one side at a time. So that side looks soldered to me. So this one here, that also looks good. Let's turn it around. That one looks good, and this last side, let's turn it around again. Where is it? Lost it. There it is. Yeah, that was, so it looks like the solder's gone under all the pins. I mean, it's near on impossible to say with these stupid QFN chips. But that's on. It seemed to me that took a hell of a lot of heat from the preheater. I couldn't even get it up to temperature I wanted with the preheater set to full and left on for a minute. There's obviously this area, this board is extremely thick with ground planes and power planes. Yeah. and that's really, you know, what's making this difficult. Okay, so anyway, that's the hard bit of the job done now. So there's now a matter of getting these 4 FETs put back on. The 2 inductors have got to go back on, and then the capacitor will put back on last. Yeah. To make life easier now, I'm going to put leaded solder on all of these to make them easier to solder. So let's go back to the desktop. So we'll just add some leaded solder to the pads where the MOSFETs go just before we solder them. These will be considerably easier to solder, I think, than the previous ones. Fingers crossed, yeah. But the leaded solder is going to help. The problem being, of course, getting enough heat into this, as you saw previously. So this is where the 2 coils came from. Okay. So we'll clean off this old solder, and then we'll put some fresh leaded solder on. A bit of flux, bit of braid, and let's see if we can get these to come nice and clean. It's looking good. It's looking good. It's looking good. A bit more. Okay, just cut that end off the braid. Start with a fresh bit. Okay, once again, bit of flux on the braid. Let's go back in again. So that's come clean now. Nice and clean. Nice and clean. It's very nice and clean. Let's get up to the pads where these FETs are as well. Well, there's a little bit of heat in the board now. Let's have a go on these ones. So again, a bit of leaded solder. I'm on the wrong ones, aren't I? Never mind, I needed to tin them anyway. After I clean, I needed to tin them with fresh solder. A bit of leaded solder around the FETs. Now let's clean this off. Flux on the braid as always. Okay, let's go for it. Yeah, clean. Clean. Careful you don't pull these pads off. You know, you don't want to be dragging the braid if it's stuck to them. Yeah, you want to make sure it's free. Okay. Ouch, that was hot. End of the braid was bloody hot, and I snipped it and pulled a little bit more off the reel. Okay. Let's suck the solder off those. The pads. That stuck a little bit then, so that's why I didn't drag it away. There's some pads here. Okay, that's got them clean. So we'll now add a bit of leaded solder on these as well. A bit of solder on the pads, just a bit on there. Make sure you get on all 4 pads. All 4 pads. Okay. all 4 pads, and then we just clean up this little bit where the capacitor came from. Putting leaded solder on will make it much easier for us to resolder this. This was their very heavy ground plane. This is the heavy one, the heaviest one. Okay, nice and shiny with leaded solder. Okay, so that's prepared the area of the board. So now it's just a matter of fitting the chips. We'll start off with these two, the lower pair of the FETs here. Yeah, I'm pretty sure these were the 3092s, which I actually made a note. They connect to ground, so let's just be 100% sure I've actually got them the right way around. Okay. So one pair of these FETs actually connects to ground, yeah. Set the meter where you can see it, there you go. So black lead's just going on the ground, on the DVI connector. Yeah, this is the ground on these pins here, and on these pins here. So none of the other pins actually go to ground, yeah? Only on here and here. So these two are the K0392s. Let's find one. Tweezers. So what we got here? That's a 392. So if you can't maybe read it, I'll zoom it in. That's the 392. Now you can read. I think that's a 392. Yeah, 392. I think you can just see that there. So these go onto these pads here, yeah, and they go this way around. So the legs are sort of towards the top up. Just to focus on that slightly for you. So like that. Yeah, with the pads to that end, yeah. It's extremely sticky now. Yeah, with the legs to that end and the pad to there. So again, we'll use the technique of getting a bit of solder onto the MOSFET itself, and then we can fit it. So once again, a little bit of flux will probably help. Hold her in place. A little bit of solder. Not too much. Tin the pins. Now let's see if we can tin this metal tab. Yeah, there we go. So that's nice, ready to go onto the board. Yeah. Take it the right way around. It's all got a bit gooey now. I might be better just cleaning a bit of this flux off, but we'll see. Can I pick this up again? Make sure it's the right way. It was the right way. You don't really want it stuck on your finger, do you? You don't really want it stuck to your finger. Yeah, it's the right way around. And what we're going to try and do is actually solder the pins, yeah? I'll do it under the microscope so we can make sure we've actually got it. One moment. Okay, so here's our MOSFET in position on the board, yeah? You should just be able to see that the 4 pins here in the pads to go to. What's quite nice about this is there's like the heatsink underneath, the tabs stick out either side. So I should be able to get some heating from the soldering iron and probably tack these down. I'll probably use hot air then just to reflow them once they're actually in place, yeah? So first off we'll find some of the thin solder, 0.2mm. And let's see if, without me holding the chip down, if I can actually tag one of the legs to the pad, yeah? See if I actually get any even do this. If I can tag them this way, makes life a bit easier, because you know otherwise I'm having to use the left hand either for the soldering iron or for the tweezers, and my left hand's not as good as my right hand. Two right hands would be brilliant. It'll look odd, but it'd be brilliant. So if I've actually got that or not. Once I got it tagged in position, I can then come in much more forcefully. No, I didn't. You see, I've not got it. Okay. I'm gonna have to hold it down while I do it. Okay. Let's try again. So we're getting some solder. I may not be able to do it this way due to the thermal, you know, the thermal capacity of the board in this area. I may have to use hot air anyway. Okay. I think now I might have it. Give it a second for the solder to actually solidify. Yeah, I've got it now. It's not exactly to the fraction of a millimetre line, but the pads are fine. I'm not going to get a short. So let's get into this one. Now with some heat. Again, I'll just hold the chip in place. Right on. Although it should be fairly solid now, to be honest. Bit of solder. I might actually add a bit of more flux. It's like this stiff, old gooey and sticky might have kind of like lost its fluxability, yeah. Effectively. So let's try that. Getting on the pin here somewhere. Some solder. Yeah, that looks better. That looks pretty good. Now try and get some into the tab underneath it. Once I've got it in place, I can then come in with the hot air. It won't blow away. Yeah, it won't move. The surface tension of the solder always in place. Okay, not exactly brilliant, but I think we can now get in with the hot air and finish that off. Yeah. Let's get the hot air on it. Okay, so here's our FET. It is attached to the board, it's not moving. So I'm now going to come in with the hot air on 450 degrees, full 120 airflow, and I'm now going to effectively reflow this FET, yeah. I'll put a bit more flux around it. When I see the flux bubbling, I'll know I've got it to the right sort of temperature, yeah. Okay. Let's warm the general area a bit. Looking pretty good. The flux evaporating. I'm pretty sure we've got that one. Okay. I'm pretty sure we've got that one. So we'll let that cool down. If that looks good, then I'll do the others. I'll look at this one. If it's good, I'll just do all the others off camera because it's the same. You don't need to see the process over and over again, I'm sure. Okay, so there's our FET. Even without taking the old flux off, it looks pretty good to me. That one does. Let's just find the paintbrush and just clean it up, and let's have a look to see what we have. It's stuck down, but I knew it was stuck down anyway, so I shouldn't be surprised. Okay. A little bit of kitchen mo on that. Yeah. I thought this solder here would have flowed under a little bit more where I got a bit on the side. It seems well stuck down though. The legs all look good. Just to get a torch often gives us a very good idea. Yeah, it looks nice and shiny. Can we adjust the focus on that a little bit to lift the edge of it a bit? Yeah. That looks like a good soldered FET to me. Okay, so what I'll do is now I'll fit the rest of them, and then we can. Well, I'll fit the rest. I may as well solder the coil and the capacitor back on. I don't think you really need to see that, so you know it's easy enough. Oh yeah, I might show you that. Why not show you everything? Okay, so let's get the rest of the FETs fitted first, and then we'll come back. Okay, so I've got all the 4 MOSFETs replaced. So it's just a matter now putting the 2 coils back and the capacitor. The coils are quite easy to do, actually. You just need to get a bit of wherever I put it. There it is. A bit of leaded solder on them, and then a bit of lead solder on the pads. And you can actually solder these with a soldering iron. They're not really a problem to do them. I just need something to hold this in place with. A bit of leaded solder. Let's just find the other one. Again, same thing, bit of leaded solder. Bit of flux would probably help that one. Okay. Other side the same. And then again the same with the pads. Okay. It's just a matter of holding them in place with the tweezers, basically. It's probably actually easiest to just have some solder on one of the pads to start off with, yeah. Leave the other one cleaned. Okay. So you got one flat one. And then we can offer the coil up to the other pad and catch it with the soldering iron, basically. So there we go. Bit of solder. And then we can just offer this towards the soldered pad. Yeah. Get in there. Some heat. Slide it into place. Same with the other one, then it's going to be easy matters, you just tag the other sides down. So let's have the other one. Again, same thing. Some heat onto the pad. Get it melting. Slide the inductor up towards it. Job done. Now we can just get the other two sides. I could do with sliding them a bit further over actually. I don't have them quite far enough across to solder that side easily. That's just easy enough. So let's just melt this. That's it. Put it a little bit further in. So just wait for the solder to solidify. Same with the other one. That's it. Now we can get to the other two pads. That's better, yeah. Try this one first because it's the most difficult to get towards. Should do it. Should do it. I'll just take a bit of a look at this tantalum capacitor here. See, I haven't just melted it. No, I think it's flux on it, but we'll clean it up and we'll have a look just to be sure that's not damaged. So it's the electrolytic. Much the same again. Bit of leaded solder underneath it. Bit of flux, no doubt, to just get it started. Okay. There's a bit of leaded solder on there, Same thing on the pads, of course, on the board. I think one of these had a very heavy ground plane in it. That's not too bad. Okay, so this went with the blue strap towards the edge of the board. I took a photo of that earlier, so I would remember it. See if we can just get into the right position. There we go. I'll solder this in place with my fingers. I think it's the easiest way with this one. I'm sure this will solder a lot easier than it's unsoldered, yeah. One moment, something's just popped up on the screen there. It's better. You couldn't see it. I could see it. It was just annoying. Okay. Where's the capacitor? There it is. So we'll get it from this side. Try to get heat onto this pad. See if that's touched or not. Maybe not brilliant. Let's have another go at that one. This is the one that had the heavy ground plane in this pad. Just to make life a bit difficult. I think that's got it now. Yeah, the same from this side. Okay, so that cooled down a little bit, and then we'll clean all the area up, and we'll make sure if it's soldered fine. It's quite warm, that is. Okay, let's So let it cool down. Let's clean it all up. Okay, so that's got the area all clean. I'm not completely happy with the soldering on these two inductors, and nor totally on this capacitor either. So what I'm going to do now is I'll use a hot air just to get these to like reflow this. It's now leaded solder, so it doesn't need to get so much heat into it. And I'm sure we can improve that. And the same with the capacitor, because it's leaded solder, it no longer needs to get so much heat in to get this to melt. So let's have a go at this. Let's start off in the area of these two inductors. The MOSFETs look good, but we'll get under the microscope to be sure. This capacitor, I thought about the damage I haven't. Let's put this hanging off the end of the board, sorry, off the end of the metal stand. Helps the heat get into it, gets the area warmed up. So you get the soldering iron on those. Now there's a lot of heat into the area. These two here, cleans up. So there's soldering iron down there. Yeah, it's flowed a lot better now. Okay. Straight away, that's looking better. And we'll come in down the side of this capacitor as well. That's probably that. If you see the liquid, that must be the isopropyl that has gone underneath it. Okay. I'm sure that solder's molten. Oh, sorry about it, guys. I took the microphone off to one side. I hope you could hear well enough what was going on there. Sorry about the bad sound. Yeah, I could see this is moved slightly, so the solder's definitely molten now. It's stuck down. So now we need to get us under the microscope. Just going to clean down the side of this a little bit while it's hot. Take some solder off. There's another component very close to that side. I want to make sure I'm not actually short into it. Okay, let's let that cool down, and then we'll straight under the microscope and let's have a look to see what we have. Okay, so it's not the neatest job ever, but everything seems to be soldered. The FETs look pretty good as the capacitor. Let's have a quick look round now, and then we'll have to fire this up and see if we've done it successfully. So this is the capacitor, one of the capacitors on the VRAM. So the coils should connect to here. That one's not very straight, but it's on. I think it moved actually when I just reflowed it. Yeah, they're okay. So they go to there. That's fine. Then on these FETs now, we should have two sides go to ground. So I'm just connecting to the ground on the DVI connector. So this goes to ground here. This is the low side. There's just a bit of crap on the end of the meter probe there. Yeah, those three go to ground. This must be the gate. So I'm assuming the same on this one. 1, 2, 3 all going to ground. Yeah, I can read this on the FET itself, so that's looking good. Same here, I'm actually on the FET rather than on the the little connections. I can get it. Yeah. Okay. So that's ground. So the other end of the two FETs would go to these other ones, and this is the junction with the coil. So from here, we should have a connection to here. Come from the other side. That's rather nicely soldered. And the same from the top side of this one. This should go to this FET here. Yep, goes. And then the other side of these two FETs will actually go to the this capacitor in this little coil here. Yeah, so let's just get from over on this one to the positive of the capacitor. See if we get onto the pin of it. Yeah, and obviously to this coil. Yeah, so that's all looking good. I've just noticed actually there's some 1 ohm resistors around here. See, these ones marked 1 or 0. Let's just check these. I didn't check them after we'd had the blown FETs, so it's worth checking any low value resistors in the area just to make sure they're okay. Those seem okay, and these probably go to the gate, I'm guessing, which is one end or the other of this. Yeah, that end. Other one must go to the other one, which is the way up, so I think it's probably here. Yeah, or is it? Oh, that's the ground side. That's why I'm reading 61 ohms, which is the resistance of the VRAM to ground. Yes, that's okay. That was pretty good. Just look at this capacitor. Yeah, I can see the legs definitely soldered. It's there. Other side. A bit hard to get a focus, but let's try to turn it round. Let's try to go at it this way. Oh yeah, now we can clearly see that the pin is actually soldered, so that's good. Oh, that was good. Just a bit untidy with this one, not very straight. The capacitor's fine. It's ready to try it, guys. It's ready to test this. Let's get the test rig put together. Let's see if it's working now. Okay, so we're pretty much ready to go, really. Just a final check. So to ground from the voltage to the RAM and part of the GPU is now 61 ohms, not 10 as we originally had. VCore will be obviously below 1 ohm, that's fine. We don't have any shorts, anything on the 12 volts coming in. Just this is 12 volts here. No, that's fine, it's just reading the resistance. 3.3, 1, 2, 3, 4th one in. Yeah, 20 odd ohms, but it's not a short. I can live with that for now. We don't have a short, as obviously we say on VCore, it's 60 odd ohms, and from 12 volts to VCore, we can just double check this. Come to the top of this capacitor. Actually, that's VCore, not VCore, sorry, VRAM from 12 volts on this coil. It's just reading a capacitor charging up, which is probably this capacitor. It's on that's on the same voltage rail, so I don't see any problems there. Not sure about 3 volts, 1, 2, 3, 4. Not sure exactly what I was going to see there, but 24 ohms. It's obviously reading, powering some parts of the GPU. I mean, it's possible this has got a damaged GPU or a damaged RAM or both because of the high side short here. So we can't say whether or not this is actually going to fix it, but we can try it. Yeah. So put a heatsink on there. We can stick the two 12 volts supplies in here. Just straight in. Doesn't want to go. Is that the wrong wire? No, it must be the right wire. Of course it is. Where's the other one? Just get it straight. That's why I didn't want. That's why I didn't want. You couldn't see what I was doing because I was just connecting these, and one of them didn't want to go in easily. That's it then. We'll clip our ground. We'll just prop it into here with a bit of luck. I don't have 3 hands. I'd like to measure the voltage that powers up. Let's just get a crocodile clip lead. not as I'm faster at switching this off than the GPU is going bang, of course, but still. Connect on there. That's connecting ground. Yeah, I've obviously got a connection, so volts. And we're hoping to see, I'm guessing here, about, I don't know, 1.2 or something like that. I'm not sure exactly, but it shouldn't be anything like 12, that's for sure. So, power on. Power supply is on. And all we can do is switch this on, fingers crossed, yeah. Okay, let's go. 1.5. Now it's powered down again. That's interesting. It was certainly correct. Oh. Wonder why she's powered down again. Well, I saw there what I expected to see. Something doesn't want to start up here. Oh, what's going on with that then? Just disconnect the graphics card, yeah. See if the motherboard powers up. This is the final seat. If it's going to power up, yeah. Power on. Oh, I see what's happened. Bad connection on the switch on the Variac. Yeah, that's powered up. We can disconnect this because we know it was 1.5. Yeah, and that sounds very reasonable. Let's just put it together the other way around. Well, so that's not good, is it? The PC will no longer switch on with the graphics card attached. The fan spins for, you know, like a little flick and stops. It's like there's a short circuit somewhere. What's caused that to happen? I don't know, because we definitely had the 1.5 volts here for a good few seconds. Yeah. Let's have a look. Let's zoom it in a bit. So, resistance, black lead to ground. V-core is still reading 1 ohm. That's as it was. And this is still reading 60. That's a capacitor charge, that's reading 60. So there's no shorts there. This is the ground end. Let's just go to the... No, there's no shorts there either. That's on the 12 volts coming in. So I have 3.3 volts down there. It's the fourth one in from this end, the 3.3 volts on the PCIe. Oh, sorry, you can't see it, can you? There you go. The 3.3 volts on the PCIe. From the notch, you count 4. 1, 2, 3, 4. 173 ohms. I think that's actually a bit more than it read before. Number five is ground, so it's definitely number 4, yeah? 173 ohms. And then this is your 12 volts. 60. That was reading about 200 before. So there's no shorts, but that's reading 60.5. What's the VRAM reading? 60.5. Okay. 12 volts to VRAM. Oh, pardon my French. We got 12 volts short to here. What's on the PCIe coming in? Ah, but okay. On the 12 volt connections up here, it's fine. But on 12 volts from the PCI fingers down here, PCIe, we have a short to VRAM. That's why it's not reading short to ground, because the VRAM is still the same. Well, the bad thing about that is we've got a short. The good thing about that is VRAM is still reading 60. And that's why we're not seeing the short to ground here, we're seeing 60. But that will explain why the PC no longer powers up, because it tries to put 12 volts into VRAM, which you would assume something draws a lot of current, and the PC, you know, the power supply as a safety feature. Well, we're going to have a look at this card now. And let's figure out how we now have a short from 12 volts to VRAM. And if we can figure that out and fix that, both lots of fingers crossed, we haven't trashed it, it might work. Okay, let's get rid of the test rig and get it on the bench, and let's have a look to see what we got. Okay, so where's the short? It's definitely, I mean, this is definitely connecting to there. There's another buck regulator coil. Sorry, buck regulator coil here. It doesn't go to there. I wonder if it was powered this. I'm pretty sure this powers like the standby for this anyway. And there's nothing else over here. There's a voltage regulator up here. No. Oh, it goes to there like reading 2 ohms, but not reading like a short like I see here. Yeah. Where else? Does it come over here? Doesn't come in over here. Oh, actually that's interesting, that, because earlier on when I was tracing out these MOSFETs for the high side to 12 volts, I couldn't see a connection to here, but I could to this coil, and I didn't bother going any further. So it would appear that the PCIe 12 volts is what actually powers this. So that's going to be high side FETs. We've got to be anti short. I think that goes to this side. Short, and this side's ground, so I'll probably read 60. Yeah. Same on both channels. Yeah. You can't, you should read the same anyway, because these two coils are connecting together. That's the 60. Ground. 60. Ground. These have gone short again. For some reason these have gone short circuit again, which is what was the original problem. So look at the controller chip down here. Let's look under the microscope. Let's get the microscope on that. Let's have a look. Okay, so here's the controller chip, yeah, and there's no holes in it anymore. That's a good sign. And it did work for what, 5 seconds or something. These are the FETs that I changed. So there's a bit of focus on them. And quite clearly, these are short circuit. Yeah. That one is. I'm sure this one is as well. Meter probe on it. Yeah, these are high side FETs, and it's quite clear they're short circuit. So what's caused that? But there again, what caused it? Well, in the first place, we said these were short, so the controller chip had got a hole in it. Well, that didn't really say why these went short in the first place. We just assumed they were failed. There's no short circuit on the output, as we know, so I'm now connecting to ground, yeah. We take it off this end of this capacitor, this is ground. And I think this is the junction of the two FETs, yeah, 60 ohms. But that's the coil, effectively, connection to the coil, yeah. the junction of the two FETs to go to the coil. So there's no short circuit output, and it didn't like fail immediately either. It like ran for like 5 seconds and then failed. That suspiciously seems to me like the GPU or the RAM is taking too much current, you know, more than this can handle. So they run for a while, get hot and just fail. The other possibility is that like these are like fake or not good replacements, but because the original ones had failed in the same way, I don't think that's the case. This is looking bad, guys. So it does seem then that these must be powered from here, and this is powered from down here. I'm not familiar with this card, so you know, I kind of make it up as I go along. Let's have a look. Yeah, there's power coming into the V core, so V core from here, and VRAM plus whatever powers up from here. And I'm guessing that this is drawing more currents, so not a short, but when this is run for some seconds, it was putting the power in here, too much current, and he failed, I think. Okay, so I think that's the end of that. I will actually ask, there's some guys on the internet who maybe have more specific knowledge about these, and I will just ask to be sure. But other than that, I think that's the end of our GTX 570, unfortunately. Okay, guys, sorry that wasn't completely successful, but I hope you can see the value of the knowledge we gain from trying to fix this sort of stuff, and I'll see you soon on another video. Cheers now.